Okay guys, so I want to go through with you to find the derivatives of tangent, secant, cosecant, cotangent. Before we begin, I noticed as I was uploading this page that there's actually a typo, so my bad. For number 4, it says secant of x, but that should actually be cotangent of x. Okay, so let's just go back up to the top and start from the beginning. So we already have figured out so far, this is what we know. We know the quotient rule, which we're going to use. It even gives us to that right here. We're using our quotient rule. And we also know the derivative of sine and cosine. So keep those things in mind as we go through each of these derivations. I'm going to do number 1 and 2 with you, and then you're expected to do 3 and 4 following the same pattern, but you're going to do it on your own. So hopefully you guys remember that the other way of writing tan of x is to write sine of x over cosine of x. Now, when I do that, that's going to give me a fraction, right? Which, oh no, don't be scared, because we now know our quotient rule from class. So we know that, remember that if you have y equals u over v, then y prime is going to equal u prime v minus v prime u all over v squared. So we're going to use that formula today. And we're going to use our derivative of sine and cosine, which we already know. So just for clarity, let's call this function y. And we want to find y prime. Now to find y prime, I need to know what u and v are, right? Because I need this formula. So just off to the side, I'm just going to note to myself so I don't get confused that u is equal to sine of x and v is equal to cosine of x. So that would mean that u prime, if I take my derivative of sine of x, you already know that that is cosine of x. So you already, sorry, that something weird happened on my end. So you already know that that is cosine of x. So then you also know that v prime would be negative sine of x. So when I plug this into my formula, I'm going to get u prime v. So in this case, u prime is cosine, so it would give me cosine of x, and v is also cosine. So cosine of x times cosine of x minus v prime, which is negative sine of x, minus u, which is also sine of x, all over cosine squared x. So if I simplify the top, that's going to give me cosine squared of x plus, right, because I end up with 2 negatives here and here. So plus sine squared of x all over cosine squared of x. Now, when I apply my trig identities, you should remember that cosine squared x plus sine squared x equals 1. So this is going to give me 1 over cosine squared of x. Now, although 1 over cosine squared of x is the derivative of tangent, we also know that 1 over cosine is secant. So 1 over cosine squared would be the same thing as secant squared of x, which is how we write our tangent property. So let's scroll ahead now and look at the bottom of the page, just so we don't forget. So we know that tan of x is equal to secant squared of x, derivative of sine of x is cosine of x, and the derivative of cosine is negative sine of x. Okay, so let's scroll up now, and I'm going to do secant with you guys and then leave you to do the other ones. So for secant, hopefully you remember that secant of x is the same as 1 over cosine of x. Now, you might be thinking to yourself, what, this is not, I can just make a negative 1 exponent and be done, and you can, but let's you do it using the quotient rule, okay? So u is going to equal 1, because that's our term on top, and v is going to equal cosine of x. So then I know that u prime would be 0, and v prime is equal to negative sine of x. So now, when I take y prime, I'm going to end up with 0 times the cosine of x minus 1 times negative sine of x all over cosine squared of x. So when I simplify this, this term is going to go to 0, and I'm left with two negatives here and here, so that'll become a positive. So I'm left with sine of x over cosine squared x. Now, although, again, that's the correct answer for secant of x, or for the derivative of secant of x, that's not actually how it appears in your textbook, or in any calc course for that matter. So if I go ahead and take my denominator and expand that, that would give me sine of x over cosine of x times cosine of x. And if I separate my fraction, that's sine of x over cosine of x times 1 over cosine of x. And hopefully you remember that sine of x divided by cosine of x is tangent, and 1 over cosine of x is secant. So because of that, we always write our derivative of secant as secant x times tangent of x. So let's go ahead and just move that into the chart at the bottom of our page. So this is secant of x is secant of x, tan of x. Okay, so as I've now said multiple times, I'm going to leave you guys the derivative of cotangent and cosecant to figure out for yourself. And I'll check that next time I see you guys in class. So let's go ahead now and just do this one example, and then you guys will do example 2 on your own. So we're going to differentiate 2 times tan to the 7th power of 5x. So whenever you guys have an exponent inside a trig function, just remember that that's the exact same thing as saying 2 tan 5x to the 7th, okay? They're the exact same thing, so feel free to use them to your advantage, okay? Make sure you guys can manipulate between this form and this form. They mean the same thing, and sometimes it's more helpful to have it look like that. So when I take my derivative here, I'm going to start with with my exponent rule. So 2 times 7 is 14 of whatever's inside my parentheses. In this case, it's just tan of 5x. And then 7 minus 1, because again, I'm just doing my exponent rule, would be 6. Now I need to look at the derivative of my inside function. So the derivative of tan of 5x, it would just be secant squared of 5x. So I'm going to multiply it by secant squared of 5x. Again, just by the chain rule, right? I'm doing the derivative of my inside function. And then hopefully you guys notice that we have another inside function here. So we also need to multiply by 5. So just putting this all together to make it look, just a little nicer, we can do 14 times 5. So 70 tan to the 6th power of 5x times secant squared of 5x. And that is your final answer, okay? Again, we talked about it in class. Sometimes your answers can be kind of ugly. It's not a big deal. So go ahead now. Whoa, sorry guys. And try number 2 on your own, number 3, and number 4. Also keep in mind when you do this function for number 2, you're going to have to use your new derivatives and the product rule. Okay, now whenever you see 2 things being multiplied, 2 functions that involve x, you need to think product rule. Okay, so go ahead and do those before you move on to the notes for the next section.